Hi dear friends, welcome to online classes. I am Virupakshi BP. Today I am going to start new chapter, that is states of matter. First let us know what is the weightage of this chapter. From this chapter they will ask 1 mark question 1, 2 mark question 1 and 5 mark question 1. Total this chapter has 8 marks weightage. Now let us start this chapter with what is matter. Matter means anything which has mass and occupies space is called matter. For example, chalk piece. It has definite mass and it occupies some space. So it is also called as matter. Matter means anything which has mass and occupies space. Is called matter. Matter mainly exists in 3 physical states. One is solid, second one is liquid, third one is gas. The first one is solid, the second one is liquid, the third one is gas. In this chapter mainly we focus on gaseous state. In second PUC we will learn about solid state and liquid state. And the physical states of matter depends on 2 factors. One is intermolecular forces and second one is thermal energy of molecules. The physical states of matter depends on 2 factors. One is intermolecular forces the second one is thermal energy of molecule. Thermal energy of molecule. The competition between intermolecular forces and thermal energy of molecules decide physical state of matter. Now let us discuss one by one. The first one, intermolecular forces. What are intermolecular forces? Inter means between molecules. Intra means within the molecule. Here intermolecular forces. The forces between molecules is called intermolecular forces. The force of attraction or force of repulsion between 2 interacting particles is called intermolecular forces. For example, these are 2 particles. The force of attraction or force of repulsion. Force of attraction or force of repulsion between these 2 interacting particles is called intermolecular forces. The force of attraction or repulsion between interacting particles is called intermolecular forces. Intermolecular forces always try to keep the particles close to each other. It is always try to keep the particles close to each other. Intermolecular forces always try to keep the particles close to each other. Close to each other. The force of attraction or force of repulsion is called intermolecular forces. Intermolecular forces always it tries to keep the particles close to each other. And ionic bond and covalent bond are not considered under intermolecular forces. Why? Because intermolecular forces are related to atoms and molecules. Here particles means atoms or molecules. The intermolecular forces are related to atoms or molecules, but ionic and covalent bonds are related to electrons. That's why ionic and covalent bonds are not considered under intermolecular forces. Ionic and covalent bonds are not considered under intermolecular forces. Next, what is the van der Waals forces? Van der Waals forces. Van der Waals forces are weak attractive intermolecular forces are called van der Waals forces. Here, what are intermolecular forces? The force of attraction or force of repulsion between two interacting particles are called intermolecular forces. Then, van der Waals forces means only attractive force. The attractive intermolecular forces are called van der Waals forces. Weak attractive intermolecular forces are called are known as van der Waals forces. Van der Waals forces. Next, let us know basic differences between solids, liquids and gases. The first one, intermolecular forces. In solids, there is a very strong intermolecular forces. In solids, there is very strong intermolecular forces. In liquids, there is a strong intermolecular forces. But in gases there is a weak intermolecular forces. The next one, intermolecular distance. In solids, due to very strong intermolecular forces, the atoms they come close to each other. So the distance between atoms is negligible. Almost it is negligible. In liquids, due to strong intermolecular force, the atoms they come close to each other, but there is a less distance between two atoms. Less intermolecular distance. But in gases, due to weak intermolecular forces, the gaseous atoms they move away from each other. So there is a large distance between atoms. So in gases there is a large intermolecular distance. Next, shapes. Solids have fixed shapes. Why? Because their intermolecular force is very strong and their intermolecular distance is negligible. Solid shapes are fixed. Liquid shapes are not fixed. And gases shapes also not fixed. Why? Because weak intermolecular force and large intermolecular distance, the shapes of gases are not fixed. Volume. Solids have fixed volumes. Why? Due to very strong intermolecular forces and negligible intermolecular distance. Fixed volumes. Liquids also have fixed volumes. But gases have not fixed volumes. Next, compressibility. See here, in solids, due to very strong intermolecular forces and negligible intermolecular distance, there is a almost zero compressibility. We cannot compress the solids. So almost zero compressibility in solids. Almost zero compressibility in solids. Why? Because negligible intermolecular distance and very strong intermolecular forces. But in liquids, due to less intermolecular distance, there is a less compressibility in liquids. Less compressibility in liquids. But due to weak intermolecular forces and large intermolecular distance, gases have highly compressibility. They have highly compressibility, high compressibility in gases. These are the basic differences between solids, liquids and gases. Next, let us know the types of intermolecular forces. The first one, dispersion forces, or London forces. The second one, dipole, induced dipole forces. Dipole forces. The third one, dipole forces. Dipole forces. The fourth one, hydrogen bonding. Hydrogen bonding. The fifth one, ion dipole forces. Ion dipole forces. The sixth one, ion induced dipole forces. Induced dipole forces. Dipole forces. These are the types of intermolecular forces. The first four intermolecular forces are van der Waals forces. Van der Waals forces. The last two forces, ion dipole forces, ion induced dipole forces, are not van der Waals forces. Not van der Waals forces. Forces, and these are important for 1 mark. Just they will ask definition. What is the dipole forces? What is dipole induced dipole forces? What is the dispersion forces? And what is ion dipole forces? Or if they ask for 2 marks, just you give one example. You write definition and you give one example. Now let us discuss one by one. The first one, dispersion forces are London forces. What are dispersion forces or London forces? The force of attraction between non-polar atoms or molecules having induced momentary dipoles is called dispersion forces or London forces. The force of attraction between non-polar atoms like helium, neon, argon, etc. These are non-polar atoms or molecules. Example, hydrogen, nitrogen, oxygen, etc. These non-polar atoms or molecules having induced momentary dipoles. Momentary dipoles is called dispersion forces. The force of attraction between non-polar atoms or molecules having induced momentary dipoles. Induced momentary dipoles are temporary dipoles. They are not permanent dipoles. We know that the non-polar molecules or atoms have no dipoles. But even non-polar molecules or atoms also get temporary dipoles at any instant of time. But generally they have no charges. Now, induced momentary dipoles are temporary dipoles. Let us take one example. This is a HCl and this is a hydrogen molecule. This is a polar molecule. Polar molecule. This is a non-polar molecule. Non-polar molecule having no dipoles. No dipoles. Here polar molecules having permanent dipoles. Permanent dipoles. Dipoles means two poles. One is the positive charge, another one is negative charge. See here, why the polar molecules have permanent dipoles and why non-polar molecules having no dipoles. See here, in polar molecules, due to electronegativity difference, polar molecules have permanent dipoles. See here what happens, here the electron density will shifted towards more electronegative atom. Here chlorine is more electronegative atom than hydrogen. So these electron density will shifted towards the chlorine atom. In that case, the chlorine atoms get partial negative charge, hydrogen get partial positive charge. Due to electronegativity difference, the electron density will shifted towards more electronegative atom. That's why polar molecules having permanent dipoles. But here what happens? Here non-polar molecules having no dipoles. Why? Because here due to same electronegativity, the electron density will not shifted towards any one atom. Here the electron density will equally distributed to both atoms. That's why non-polar molecules have no dipoles. Why non-polar molecules have no dipoles? Because electron density is symmetrically distributed. But in polar molecules, the electron density is not symmetrically distributed. Here unsymmetrically distributed. Here electron density is more on more electronegative atom, less on less electronegative atom. That's why polar molecules get a partial negative charge and partial positive charge. Even non-polar molecules also get temporary dipoles at instant of time. Now let us check one example. Just I am considering two non-polar atoms, atom A and this is atom B. Nucleus is present at the center of the atom and electrons are revolving around the nucleus. These two atoms are non-polars. Non-polar atoms have no dipoles. Non-polar atoms have no dipoles, but at instant of time both non-polar atoms get temporary dipoles. At any instant of time, we believe that the electron density of B atom will shifted towards any one end of the B atom. Either it shifted towards right side or left side end of the B atom. In such cases, B non-polar atom gets temporary dipoles. Let us see here. The non-polar A atom with no dipoles. Non-polar atom A with no dipoles. dipoles. But we believe that at any instant of time, the electron density of B will shifted towards any one end of the atom. Just I am considering here, the electron density will shifted towards right end of the B atom. Right end of the B atom. See here, this is a non-polar B atom. At any instant of time, the electron density will shifted towards right end of the B atom. Then nucleus will shifted towards left end of the B atom. In this case, the left side end gets partial positive charge and the right side end gets partial negative charge. Here, the non-polar atom B is with dipoles. These dipoles are not permanent dipoles, they are momentary dipoles. Here non-polar atom B with momentary dipoles. Due to presence of momentary dipoles on B atom will attract these electron density towards itself. When it attracts electrons towards itself, then electrons will move towards right end of the A atom, nucleus will move towards the left side end of the A atom. Then A non-polar atom A also gets momentary dipoles. See here, this is atom A and this is atom B. Here, due to attracting electron density, the electron density of A will shifted towards right end of the A atom and the nucleus will shifted towards the left end of the A atom. This end gets partial positive charge and this end gets partial negative charge. Here already the non-polar B atom with the momentary dipoles. It is a partial positive charge and this is partial negative charge. Here the A atom, this is A atom, this is B atom. In this case, both non-polar atom A and B have momentary dipoles. Due to presence of momentary dipoles, there is a weak force of attraction between both atoms A and B. This is called London forces or dispersion forces. Here see, both atoms have momentary dipoles. Due to presence of momentary dipoles on both atoms, there is a weak force of attraction between two non-polar atoms. This force of attraction is called London force. London forces. What is London forces? The force of attraction between non-polar atoms or molecules having induced momentary dipoles. Point. Energy of interaction. Energy of interaction. Energy of this interaction is proportional to 1 by r power 6. Here r means distance between two particles. Distance between two particles. See here, the force of attraction is inversely proportional to the r. If there is a large distance between two particles, then there is a less force of attraction. If there is a small distance between two particles, then there is a large force of attraction. Energy of interaction or force of attraction is inversely proportional to the r. R means distance between two particles. And these type of forces are important only at short distance. These type of forces are important only at short distance. The next one, the magnitude of London forces depends on polarizability of non-polar molecules and geometry of the molecules. The magnitude of London forces depends on polarizability and geometry of molecules. Next point, London forces increases with increasing in size. London forces increases with increasing in size, increasing in molecular weight, increasing in surface area. London force, it depends on size, molecular weight, surface area. As size increases, London forces increases. As molecular weight increases, London force increases. As surface area increases, London forces increases. See here, this I am considering two atoms. One is small atom and another one is a large atom. In small atom, there is a small distance between nucleus and electron. In large atom, there is a large distance between nucleus and electrons. Here, due to small distance, there is a large force of attraction between nucleus and electron. That's why electron density cannot easily polarizable. But in large atom, due to large distance, there is a less force of attraction between nucleus and electrons. That's why these electron density can easily polarizable. As size increases, polarizability increases. As polarizability increases, London force increases. That's why larger molecules can easily polarizable. Larger molecules can easily polarizable. One example, fluorine, chlorine. Between these two molecules, which molecule has more London forces and which molecule has more boiling point? How can you decide the London force and boiling point? Boiling point can decide on the basis of London forces. Then London force, it depends on what? It depends on size. Between these two molecules, which is larger in size, fluorine or chlorine? According to general trend, from top to bottom in the periodic table, size increases. According to that, chlorine is larger in size than fluorine. So, chlorine has more London forces than fluorine. Because as size increases, London force increases. As London force increases, boiling point also increases. Boiling point increases. Boiling point can decide on the basis of London forces. One more example, N-pentane, isopentane and neopentane. See here, N-pentane, N means straight chain. Pent means how many carbons? 5 carbons. En means single bond. CH3, CH2, 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 CH3. See here, there are 5 carbon atoms and it is a straight chain. Isopentane. Iso means a single branch. CH3, CH2, CH, CH3. This is isopentane. Neopentane means 2 branches. CH3, CH, CH3, CH3 and CH3, sorry, CH3, CH3, CH3. N-pentane boiling point is 309 degrees Celsius and isopentane boiling point is 302 degrees Celsius and its boiling point is 283 degrees Celsius. See here, why the boiling point decreases from N-pentane to neopentane? See here, as number of branches increases, it is a straight chain. Here one branch, here there are two branches. As number of branches increases, the molecules becomes compact. The molecules become compact. That means surface area decreases. As surface area decreases, London forces decreases. As London force decreases, boiling point decreases. Okay, compact molecules. Here I will write compact molecules. Compact molecules have less London forces. That's why they have less boiling point. Next type of intermolecular forces is dipole induced dipole forces. What is the dipole induced dipole forces? The force of attraction between polar molecules having permanent dipoles and non-polar molecules having induced dipoles is called dipole induced dipole forces. The force of attraction between polar molecule having permanent dipoles and non-polar molecules having induced dipoles. Non-polar molecules having induced dipoles. Induced dipoles is called dipole induced dipole forces. Now let us take one example. For polar molecules I will take HCl molecule. For non-polar molecules I will take hydrogen. This is a polar molecule. Polar molecule. This is a non-polar molecule. This is non-polar molecule. See, polar molecules having permanent charges due to electronegativity difference between hydrogen and chlorine. Polar molecules, HCl molecules get permanent charges. Here, chlorine is more electronegative atom than hydrogen. That's why chlorine gets partial negative charge and hydrogen gets partial positive charge. Polar molecules have permanent charges, but non-polar molecules have no dipoles. Why? Due to same electronegativity, non-polar molecules have no dipoles. But when non-polar molecules comes in contact with polar molecules, due to permanent charges, polar molecules they develop charges on non-polar molecules. HCl, here partial negative charge, this is partial positive charge. This is polar molecule. When non-polar molecules comes in contact with polar molecules, due to presence of permanent charges, polar molecule develops charges on non-polar molecules. This is partial positive charge and this is partial negative charge. This is non-polar molecule with induced dipoles. Induced dipoles. Here polar molecules with permanent dipoles. See here, due to presence of permanent dipoles and induced dipoles, there is a force of attraction between polar molecule and non-polar molecules. This force of attraction is called dipole induced dipole forces. See here, due to presence of permanent dipoles and induced dipoles, there is a force of attraction between polar molecule and non-polar molecules. This force of attraction is called dipole-induced dipole forces. Next, the energy of interaction. Energy of interaction is proportional to r power 6, 1 by r power 6. Here the energy of interaction or force of attraction is proportional to 1 by r power 6. Here r means distance between two particles. Distance between two particles. Next, here the induced dipole moment values are depends on polarizability of non-polar molecule, and it depends on permanent dipoles, the dipole moment of permanent dipoles. Induced dipole moment depends on polarizability of non-polar molecule and it depends on dipole moment of permanent dipoles. Dipole moment of the permanent dipoles. This is called dipole induced dipole forces. The third type of intermolecular forces is dipole forces. What is dipole forces? The force of attraction between polar molecules having permanent dipoles is called dipole forces. The force of attraction between polar molecules having permanent dipoles is called dipole forces. What is dipole forces? The force of attraction between polar molecules having permanent dipoles. Let us take one example. I will take both polar molecules, HCl. This is also polar molecules, this is also polar molecules. This is also polar molecule. Polar molecules having permanent dipoles. Due to electronegativity difference, more electronegative atom gets partial negative charge, less electronegative atom gets partial positive charge. Here chlorine is more electronegative atom than hydrogen, so it gets partial negative charge, hydrogen gets partial positive charge. Here due to permanent charges, there is a force of attraction between two polar molecules. Here due to permanent charges or due to permanent dipoles, there is a force of attraction between polar molecules. This force of attraction is called dipole forces. Dipole forces. Now here the force of attraction or energy of interaction is proportional to 1 by r power 3. E is proportional to 1 by r power 3. This is for stationary polar molecules. polar molecules. Next, E is proportional to 1 by r power 6. This is for rotating polar molecules. Rotating polar molecules. The force of attraction is proportional to 1 by r power 3 for stationary molecules. For rotating molecules, E is proportional to 1 by r power 6. Here r is the distance between two polar molecules. Distance between polar molecules. Two polar molecules. This is called dipole forces. The fourth one is hydrogen bonding. Hydrogen bonding is a special case of strong dipole forces. It is a special case of strong dipole forces. Dipole forces. And hydrogen bonding is shown only by limited number of elements. It is shown by only limited number of elements. Limited number of elements. And if you have already learned what is hydrogen bonding and the types of hydrogen bonding in previous chapter. This is hydrogen bonding and dipole forces. The fifth type of intermolecular forces is ion dipole forces. What is ion dipole forces? The force of attraction between ion and polar molecule having permanent dipoles is called ion dipole forces. The force of attraction between ion and polar molecule having permanent dipoles is called ion dipole forces. Now let us take one example. This I am considering Na plus ion and HCl molecule. Here this is ion, this is polar molecules. This polar molecule have permanent dipoles. Due to electronegative difference, chlorine gets a partial negative charge, hydrogen gets partial positive charge. Due to presence of charge on ion and permanent dipoles on polar molecules, there is a force of attraction between ion and polar molecule. This force of attraction is called ion dipole force. Okay, what is ion dipole force? The force of attraction between ion and polar molecule having permanent dipoles. And here the ion dipole forces are depends on dipole moment of permanent dipoles and charge on the ion. It depends on charge on the ion and it depends on dipole moment of permanent dipoles. This is called ion dipole forces. The sixth one is ion induced dipole forces. Ion induced dipole forces. What is ion induced dipole forces? The force of attraction between ion and non-polar molecule having induced dipoles is called ion induced dipole forces. The force of attraction between ion and non-polar molecule having induced dipoles is called ion induced dipole forces. Let us take one example. Just I am considering ion, same ion, Na plus ion. This is ion. There is a positive charge on Na ion. Next I am considering non-polar molecule. Just I am considering hydrogen. This is non-polar molecule. Here non-polar molecules having no charges. They have no charges due to same electronegativity. They have no charges. But when non-polar molecules comes in contact with ion, this ion due to charge on ion, they induces charges on non-polar molecules. Here ion Na plus. When non-polar molecules comes in contact with ion induces charges on non-polar molecules. This is partial negative charge and this is partial positive charge. Here it is a non-polar molecule with induced charges, induced dipoles. See here, due to presence of charge on ion and induced dipoles on non-polar molecules, there is a force of attraction between ion and non-polar molecules. This force of attraction is called ion induced dipole forces. This is called ion induced dipole forces. This is called ion induced dipole forces. And ion induced dipole forces are depends on two factors. The one is it depends on charge on the ion. It depends on charge on the ion. And the second one is polarizability of non-polar. It depends on polarizability of non-polar molecule. Polarizability of non-polar molecule. This is called ion induced dipole forces. Till now we have discussed 6 types of intermolecular forces. Now let us know order of intermolecular forces. Ion dipole forces is greater than dipole forces. Dipole forces is greater than ion induced dipole forces. Ion induced dipole forces is greater than dipole induced dipole forces. Dipole induced dipole forces. Dipole induced dipole forces is greater than London forces. Now tell me, which is the strongest intermolecular forces? Ion dipole forces is strongest intermolecular forces. Then which is weakest intermolecular forces? London forces. This is weakest intermolecular forces. Which is strongest intermolecular force? Ion dipole. This is the strongest intermolecular forces. This is the order of intermolecular forces. The next one is thermal energy. Thermal energy. What is thermal energy? It is energy of a body arising due to motion of its atoms or molecules. Just I am considering one body or any substance. This substance contains atoms, molecules. In the body or in the substance, atoms or molecules are continuously in motion. They are in continuously motion. Due to motion, this body gets some energy. That energy is called thermal energy. It is energy of a body arising due to motion of its atoms or molecules. Motion of atoms or molecules. And thermal energy is directly proportional to the temperature. As temperature increases, kinetic energy increases. As kinetic energy increases, thermal energy increases. Thermal energy is directly proportional to the temperature of substance. As temperature increases, thermal energy increases. And thermal energy always try to keep the particles away from each other. Thermal energy means it is the energy of body arising due to motion of atoms. Due to motion, the particles move away from each other. They are not comes close to each other. They move away from each other. That's why thermal energy always try to keep the particles away from each other. Thermal energy always try to keep the particles away from each other. Keep the particles away from each other. Away from each other. This is called thermal energy. Now let us compare thermal energy and intermolecular forces. Intermolecular forces. Intermolecular forces versus thermal energy. What is the difference between intermolecular forces and thermal energy? Intermolecular forces always try to keep the particles close to each other, but thermal energy always try to keep the particles away from each other. Now let us see the intermolecular forces and thermal energy in three different physical states. There are three physical states, right? Solid, liquid, and gas. From solid to gas, intermolecular forces decreases, but thermal energy increases. From gas to solid, intermolecular force increases, thermal energy decreases. As the intermolecular forces decreases and thermal energy increases, solids will converted into liquid, liquid is converted into gas. As the intermolecular forces increases, thermal energy decreases, gases will converted into liquid, liquid is converted into solid. This is the differences between intermolecular forces and thermal energy.